next speaker is Sandeep Unnikrishnan from LionVolt, where he is a co-founder and CTO. Hello. And LionVolt is a company that is developing 3D structured electrode materials. And the topic of Sandeep's talk is enabling next generation lithium metal batteries. So, stage is yours. Please go ahead.
And thank you, Shark, for the introduction. Good afternoon, everybody. It's a pleasure to be here in this talk. So it's a broad, wide audience. LionVolt has been not making public appearances since its founding 4 or 5 years ago, approximately. We are now kind of in a stage where we are ready to actually advertise ourselves and the developments we do within the company to make a big difference in the next generation batteries. So my talk is going to focus on enabling next generation lithium metal batteries, specifically that as a starting point, and then thereon I can show you for slides how do we go further in our roadmap. So the world of batteries is not new for the audience, I guess. In case there are broader audiences here, I just want to look at the history of developments on batteries, and major focus being on energy density. The world has come very far, and lithium-ion batteries have been now seen as more dominant kind of chemistries for energy density purposes. And even that is seen limiting, and thereby new developments on silicon kind of anodes or lithium metal kind of anodes. Also on the cathode side on sulfur kinds of chemistries. And solid state is seen as an enabler to make sure lithium metal anodes can be used in terms of higher safety and high cyclability without compromising on energy density. Now, if you look specifically and zoom into lithium metal batteries itself, the advantage of having lithium metal in there is obviously the higher specific capacity of lithium metal, 10 times than graphite, but also the redox potential of lithium metal helps in here, and quite light weight, so low density chemistry is lithium metal. The advantage leads to good energy density gravimetrically, but also volumetrically, especially when you use anode-free kind of stack chemistries. But it comes with a disadvantage, quite known by now in the world of lithium metal researchers, is on dendritic and porous lithium formation, also dead lithium forms, primarily in liquid electrolytes, but also in solid-state electrolytes. There are researches going on grain boundary-based growth of lithium dendritic structures to make a short circuit. So these are the clear challenges lithium metal has to address. These are specifically related to the electrolyte lithium metal interface, where the SEI is kind of unstable and lets break itself and reform again in every plating and stripping cycle. Now, obviously, the world has been working on several solutions, especially being researched are on coating lithium metal surface with specific coatings, be it organic or inorganic coatings. But also at the same time looking into can a structuring approach happen on the anode side, or can the electrolyte be improved further? So on the right side of the slide, I just categorize in a group two major groups of developments around the world to enable lithium metal batteries of future. One is on the electrolyte side. There are a lot of companies around there today looking into can we improve the electrolyte, be it liquid, be it hybrid or semi-solid, but also all solid state kind of chemistries to enable lithium metal, high energy density and safe batteries. But there are also researches in academia going on electrode design and partly in industry and also on coatings on electrodes. This is the other group of activity going on. And we at LionVolt are focused on the second group, which is really designing and redesigning the electrode and having very clear thin film coatings on them to make them compatible and to cycle them quite fast and quite rapid with good energy density and good cycle life. So that brings me to the slide about what we offer as what do we develop. Now, if you look at the left end of the slide, you see the standard graphite, NMC, or graphite, any other kind of cathode chemistry put in there, which has a good cycle life, but of course limits on energy density because of the bulkiness of the graphite or the weight of the graphite added to the cell. The right end of the slide, you see lithium metal as one of the potential solutions there, obviously improving the energy density of the cell volumetrically and gravimetrically, thanks to the lithium metal anode in there. but it drops down in terms of